Hi everyone, you're welcome to DML Physics Concept. Thank you for watching this video. Make sure you like this video, subscribe to this channel, and turn on the notification bell so that when I drop the next video, you'll be able to see those new videos by the time I drop it. You can also make comment in the comment section what you want us to do, how you want us to improve in our videos on our classes. So if you have any question as well, you can also drop your question in the comment section below. Thank you. Now today we want to continue and probably conclude this topic we started with, which is current electricity. We've been able to look at some formulas we'll be using. We started by saying when resistors they are in series and parallel, we also deduce some formulas. So these are the formulas that we'll be using. And in physics, we know that we have formulas that we use, but it's not only knowing that we have formulas. The right concept of the topic and the right knowledge of how to apply the formula is also very important. So you may have formula and not know how to use it. So it's very important to understand the concept. So it's a concept that will inform you on the right approach on how to use the formula. But let's write down the formula to see the formula we'll be using. So let's look at the formula once again. Now, if we are having a series connection, then total resistance is going to be R1 plus R2 plus R3 until Rn, that is depending on the numbers of resistors we have. If we have 4 resistors, we go to R4 and so on, depending on the number of resistors. So in series connection, we had like this. And then if it is a parallel, so this one is for series connection. So for parallel connection, if it is parallel connection, then 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3. This is for parallel connection. Remember in the previous video I've explained how to determine a series circuit and a parallel circuit and how to calculate the equivalent resistance in it. So if you want to go to that video, you can just go to the description link. I will drop the link to those previous videos. You can also watch to help boost your understanding. Then we'll also be using this formula, which is V equals to IR. That is the Ohm's law. So that is Ohm's law. So this is mathematical representation of Ohm's law, which states that the current is directly proportional to the potential difference, provided the resistance of the circuit is kept constant. So that's very important. Then I want you to note something as well, because why I'm saying this is because if you understand this concept we are dealing with, it will help you to get the next thing we'll be doing as we move to the next examples. So you must note that in a series connection, when resistors are in series, the current is the same for each of the resistor, irrespective of the value of the resistor. Resistors can have different values. We can have 2 ohm resistors, we can have 3 ohm resistor. Irrespective of the value of the resistor, as long they are arranged in series in a circuit, current is the same for all resistors, but their voltage is different. So their voltage depends on the value of each resistor. So a resistor of 2 ohm and a resistor of 3 ohms will not have the same voltage across them if they are arranged in series in a circuit. So you have to get that concept that when resistors are arranged in series, then current is the same for the resistors, while the potential difference is different. Then let's look at the second concept. When resistors are now arranged in parallel, then the current high is different for each of the resistors, while the voltage across each resistor is the same. So you have to get this concept, you put it at the back of your mind, because all these concepts you have on the board is what we'll be using to solve the following questions that we'll be going into. Let this concept be at the back of your mind. Alright, let's move to the first example now. So let's look at this circuit now. If you look at this circuit is connected across, there's a 9 volts battery that is allowed to supply current through these 2 resistors. We want to determine, the first one, find the current. What's the current supplied through this circuit? Then number 2, we want to find current through these 2 ohms. We want to find current through this one, through 3 ohms. Find voltage across this and find voltage across this. So now let's bear in mind in our concept that if circuits are arranged in series, they will have the same current, whereby the voltage will be different. And when they are arranged in parallel, we have different current but the same voltage. So the first thing is we need to know, is this a series connection or a parallel connection? So let's look at it. Let's current start here. So when current moves here, when current gets here, it moves here. So the current split into 2, but the one that moves here moves through this and moves through this. So in other words, It means as current flows, the current that flows through here flows through here. So it means this one and this one, they are in series. So the first thing you need to do is to find the total voltage of the circuit, the total resistance of the circuit, and total current in the circuit using V equals to IR. So let's first do find equivalent resistance of the circuit. Since they are in series to each other, then we are going to say R total is going to be R1 plus R2. So in that case, our R total is going to be 2 plus 3, which is 5 ohms. So the total resistance of this circuit is 5 ohms, while the total voltage, that is the voltage from the source, is 5 ohms. So let's pick parameters. So the R total is 5 ohms, and what is the V total? The V total is 9 volts. So the next thing is, let's find the current. So question number 1, find the current high in the circuit. You discover that before I start looking for the current high in the circuit, the first thing I note is to find what is the total resistance of the circuit and determine the total V, total high. So it's very important to know the overall resistance of the circuit, the overall current in the circuit, the overall potential difference in the circuit. It will help you to analyze the circuit better, to know what you are looking for. Alright, in this case, we want to know the current now. So since we have R, we have V, and we are looking for high, that is the total high in the circuit, which is unknown. So if you look at these parameters, the relationship between the parameters is given by V equals to IR. So let's find our high. Then our high is going to be V over R. So what is our V? Our V is 9. And what is our R? Our R is 5. So if I divide V 9 over 5, I'm going to have 1.8. 1.8 because current is in amperes, so 1.8 ampere. So that number 1 has been solved. So this 9 volts is able to supply 1.8 current. So as current is moving out from the source, it is 1.8 current that will be in this circuit. If the voltage is 9 volts, the current in this circuit is 1.8 ampere. So let's look at number 2. Find the current through the 2 ohms. So what we are saying is that 1.8 ampere flows from the source, and when it gets here, it enters here, it enters here. So what is the concept? The concept is that when resistors are arranged in series, they are going to have the same current. So therefore, if 1.8 ampere flows from the source and it flows into these two resistors, then it means the current that flows through this one is 1.8 ampere, and current that flows through here is 1.8 ampere along that cycle. So in a series connection, the current that flows through the circuit is the same. That flows through the resistors is the same. Therefore, high across 2 ohms is also 1.8 ampere, and at the same time, the current through the 3 ohm resistor is also 1.8 ampere. So let's now move to the next thing now, to find the voltage across the 2 ohms and the voltage across 3 ohms. So let's find the voltage. Now we have the concept that when they are in series, they are not going to have the same voltage. Good. So let's find the voltage across this place. So the voltage across this place, using Ohm's law, V equals to IR. So the voltage across this place is product of the current across this place multiplied by the resistance at this point. So the voltage across this place equals to the high at this point. And what is the high at this point? The current at this point, that is 1.8, multiplied by what is the resistance at this point? Resistance at this point is 2. So we can say the voltage at this point is going to be 1.8 times 2. And that's 3.6 volts. So let's look at voltage across this one now as the second voltage across the 3 ohms. The voltage across 3 ohms is also using V equals to IR. So the voltage across 3 ohms is going to be current across 3 ohms. You know they have the same current. It's still 1.8. And what is the resistance there? 3. So we are going to have 1.8 multiplied by 3. And 1.8 multiplied by 3 is going to give us 5.4 volts. So it means the voltage across this place is 5.4 volts. The voltage across this place is 3.6. If you had the voltage, the total voltage must equal to the voltage across the two. So if I say 5.4 plus 3.6 is going to give me 9 volts. So the voltage from the source go through here and split into 2, because the voltage across a resistor, when they are in series, they are different. So we'll be able to solve these questions. You can go through this question again, and then we move to another example. This example 2. Now let's look at this example 2. Let's say we have the resistance 2 ohms and 3 ohms, but at this point now they are arranged in parallel. So we will also do the same thing as we did for example 1. We are going to find the total current in the circuit. We are going to find current across 2 ohms, across 3 ohms. Then we find the potential difference or the voltage across 2 ohms, across 3 ohms. So the first thing you need to do is first find what is the total resistance of the circuit. Then what is the total resistance, what is the total voltage, what is the total current. That's the first thing you need to find out. Now, you first ask yourself, is it a series connection or parallel? It's a parallel, because when current flows there, it's going to split into two. So it's a parallel connection. As it's a parallel connection, let's find our total resistance using 1 over R total equals to 1 over R1 plus 1 over R2. So 1 over R total is going to be 1 over 2 plus 1 over 3. So let's find the LCM, 6. So 1 over R total is going to be, so it's going to be 2 and 3, that's going to be 3 plus 2. So 1 over R total is going to be 5 over 6. So if 1 over R total is 5 over 6, you cross multiply. And when you cross multiply, we have 5 RT equals to 6. So RT is going to be 6 over 5 ohms. So let's make it in decimal fraction. So we are going to have 1.2. 6 over 5, that's going to give us 1.2 ohms. So what we are saying in essence is that the total resistance of this circuit is 1.2 ohms. So let's put something down. So the total V is 9 volts, and the total R is 1.2. So let's find the total high. So the total high using V equals to high R. So we say high also is V over R. And what is the total V? The total V is 9 and total R is 1.2. So the total current in this circuit is going to be 9 divided by 1.2. So 9 divided by 1.2 is going to give us 7.5. 9 divided by 1.2 is going to give us 7.5 ampere, because current is in ampere. So the total current in this circuit is 7.5 ampere. So the next thing is that we want to look for current across these 2 ohms. So the current across these 2 ohms using V equals to IR. So the current across these 2, so I is going to be V over R then. So current across these 2 ohms is going to be voltage across these 2 ohms divided by the resistance here. So the current across these 2 ohms is going to be voltage here divided by resistance, which is 2 ohms resistance. So what is the voltage here? The concept makes us to understand that when cells are arranged in parallel, they are going to have the same voltage. So what is the voltage? The voltage that comes from the source there, which is the 9 volts. So they have the same voltage. So the voltage here is 9 volts. The voltage here is also 9 volts because they are in parallel. So the concept is very important in using formulas in physics. If you don't understand the concept and you just speak formula, you'll be confused. So get it clearly. So when it is arranged in parallel, they have the same voltage but different current. So what's the voltage here? The voltage here is 9. And what's the resistance here? The resistance here is 2. So if I divide this by 2, I'm going to have 9 divided by 2 is going to give me 4.5 ampere. So you're going to have 4.5 ampere. So now let's look at current across these 3 ohms. The current across these 3 ohms is also going to be I equals to V over R. It's going to be voltage here, and because they are in parallel, so they have the same voltage. The voltage is still 9 volts, and resistance there is 3. So the current across this 3 ohm resistor is 9 over 3, and 9 over 3 is 3 ampere. By the time you discover that when current flows from the source, the total current that flows from the source is 7.5. But when the current gets to this point, it splits into 2. And how does it split into 2? If you check it, 4.5 flows through 2 ohms, while 3 flows through 3 ampere flows through 3 ohms. Then comes back again, it becomes 7.5, and the circuit continues like that. So let's look at the next one, which is the voltage across 2 ohms and 3 ohms. So we don't need to do any calculation, just apply the principle or the concept. So because they are in parallel, the voltage across this one, they are equal. So voltage across 2 ohms equals to the voltage across 3 ohms, and that voltage is 9 volts. So make sure you go through the video again as we move to the next example now. So let's look at this example 3. In this example 3, we have combination of a series connection with a parallel combination. So you need to pay attention very well. We are still going to apply the concept. So what we are doing also is to find the total current in the circuit. After that, find current across each of the resistors, and at the same time find voltage across each of them. So the first thing you need to do is find the total current, the total voltage, and total resistance. So let's first look for the total resistance. So to find total resistance, since this one and this one, they are parallel to each other. So let's do the parallel combination very fast. So the formula is going to be 1 over R total equals 1 over R1 plus 1 over R2. So 1 over R total is going to be 1 over 3 plus 1 over 3. So 1 over R total is going to be FCM is 3. So here is going to be 1 plus 1. That's 2. So 1 over R total is going to be 2 over 3. I believe this one is just normal mathematics that you need to understand. Then you cross multiply. The R total is 3 over 2. And what is going to be 3 over 2? The 3 divided by 2 is going to give us 1.5. That is 1.5 ohms. So the total resistance in this circuit, the total R. So let's look at total R. The total R is 1.5. So let's simplify this circuit. If I redraw this circuit, it's going to be like this, like I did the last class. So if you have not watched the video for the last class, make sure you go through that video. I will drop the link in the description below. So this one is 2 ohms, and this one has come together to give us 1.5. So this is 1.5 ohms now, and this voltage is 9 volts. If you look at it now, this question has been reduced to the example 1, the first example 1. It's more or less like example 1. So we have a series. So we'll just proceed from here and solve it like we did for example 1. So let's quickly do that now. What is the total current in the circuit? So let's find the combination of this one. So we just say, since they are in series, R total now is going to be R1 plus R2. So which is going to be 2 plus 1.5. So the total resistance in this circuit is going to be 3.5 ohms. So the overall resistance of this circuit is 3.5. So let's find our total current. So using V equals to I R, our total current is going to be our total V divided by our total R. And what's our total V is 9 volts, 9. And what's our total R? 3.5. So if we solve that now, so 9 divided by 3.5 is going to 9 divided by 3.5. 9 divided by 3.5 is going to give us 2.57. Approximately, let me just say 2.6. So 2.6 ampere. Remember, we approximated the value to 2.6 ampere. It's actually 2.57 decimal. There are many other. So I just make it to just approximate it like that. So the next thing is, let's find. So this is the total current in the circuit. So what is now going to be current across 2 ohms? So it's straightforward. Current across 2 ohms. Current across these 2 ohms is known already. It's going to be 2.6. But let's go back to these questions. Why? Because they are series. It's a series connection. Current here is 2.6, and current here is also 2.6. Good. But what is going to be current across 3 ohms and 3 ohms? The current across 3 ohms is not 2.6. The current across 1.5 is 2.6. Good. But that 2.6, when it gets at this point, remember this 3 and 3 is simplified to 1.5. That's what we simplify here. So what the current that's coming from the source now is 2.6. When 2.6 comes in, 2.6 enters here. And when 2.6 comes here, the 2.6 splits into 2. It splits into 2 before it comes out. And then we have it that way. So you need to analyze the questions using the concept. That's how we solve this question. So let's begin to take it further. So the first thing is, let's find the current that passes these 2 ohms. So the current that passes these 2 ohms is the current that's coming from the source, and automatically is 2.6. So current across the 2 ohms is also 2.6 ampere. So now let's look at the current across these 3 ohms. The current across the current that enters to the 2 now is the same. So the current here is not 2.6 as I said earlier, but what is going to be the voltage here? We need to analyze that also. So how do we analyze that? Let's come back here and solve this. Remember, this one is what we are going to use. It's more like the example 1. So we are using this one to explain further. So when current flows there, 2.6 flows there, 2.6 flows there. So let's know voltage that passes here. Let's know the voltage that passes here. Why do we need to look for the voltage that passes here? Why? Because when the current passes here, since the current that passes here is not 2.6, then to know the current that passes through here, I must know the voltage that passes through here. Because if I want to say V equals to I is going to be V over R. So if the current that passes through here, as we have rightly seen, that is not 2.6, then to know the current that passes through here, it means I must know the resistance here, which is 3 ohms. That one is given. But at the same time, I must know the voltage that passes here. So that's why we need to know the voltage by coming back here to determine the voltage that passes through here and voltage that passes through here. So how do we know the voltage that passes through here? I want to know voltage that passes through here. So let's first look at voltage that passes through 2 ohms. The voltage that passes through 2 ohms is going to be current that passes through 2 ohms multiplied by resistance here, which is the current is 2.6 multiplied by what's the resistance here? 2. So voltage here is going to be 2.6 multiplied by, and that is 5. That is 5.2. Yes, 5.2 volts. So the voltage that passes through here is 5.2. So let's look at the voltage that passes through here. So the voltage that passes through 1.5 is going to be current that passes through 1.5 multiplied by resistance here. And what's the current that passes through here? If 2.6 ampere flows from here, so definitely because they are in series, 2.6 ampere will pass here, 2.6 ampere will pass here. So it's going to be 2.6 also, then multiplied by 1.5. So let's look at that. What is 2.6 multiplied by 1.5? So that's going to be 3.9 volts. So if we add these two together, it's going to give us this. If you look at it, it's not exactly 9 volts. If I add it together, it's because I approximate the value here. So it doesn't matter. If I use the exact value, we are going to get exact 9. Because I'm using an approximated value, 2.6, that's why it's like, if I add this one together now, it's going to give maybe 9.1. So that's why it's a little different, but it should be exact value. You know, we are just doing calculations. And I use approximated value to solve the question here. So let's now go back to the question now. We are looking for current that passes. Now, we have gotten the voltage that passes here and current that passes here. The current that passes here is 2.6 and voltage that passes here is 5.2. Now, let's now look at this. What is the current that passes here? The current that passes here, so let's look at it. What is the current? I across 3 ohms. I across 3 ohms is going to be V across 3 ohms divided by resistance here. And what's the voltage across this place? Remember, the voltage that passes here is 3.9 volts. So which means the voltage that passes through the two of them is 3.9 volts. Since they are in parallel, remember in parallel connections, they will have the same voltage. They will have the same voltage. So the voltage is the same. So because their voltage is the same, it means 3.9 volts passes here. 3.9 volts also passes here. So for this one, it's now going to be 3.9 divided by 3. So what is 3.9 divided by 3? Then it's going to be 1.3 ampere. So the current that passes through here is 1.3 ampere. So let's look at the current that passes through here now. The current that passes to the second one, will also be 3 ampere because it's the same thing. They have the same equal resistance. So if I want to say 3, because it's 3, we are also going to get the same result, 3.9. So it means current that passes here is also 1.3. So let's look at the concept critically. It means from the source, 2.6 flows from the source. 2.6 current, ampere. The 2.6 enters here. But when the 2.6 gets here, it splits into 2. 1.3 passes here, 1.3 passes here. The reason why 1.3 and 1.3 pass is because they have the same resistance. That's why they share equal current. So when the 1.6 come back, if you see 1.3 plus 1.3 is 2.6. And then the cycle continue like that. So I've been able to answer all the questions they may ask us. So let me just review the question again. If they ask us what is the total current in this circuit, the total current in this circuit is 2.6 ampere. What is the current across these 2 ohms? The current across these 2 ohms is also 2.6 ampere. What is the voltage across these 2 ohms? The voltage across these 2 ohms is 5.2 volts. What's the current across 3 ohms? The current across 3 ohms is 1.3 ampere. The current across this one also is 1.3 ampere. What is the voltage across this place? The voltage across 3 ohms is 3.9. That's what we've calculated here. What is the voltage across this place? Is also 3.9 because the two of them, they are in parallel. And in parallel combination, they are going to have the same voltage, just that the current will be different. So I expect the current to be different, but the reason why they don't have the same different current is because they have the same resistance. If the resistance is not the same, the current will differ, say, and you'll be able to see the concept clearly. All right, thank for watching this video. If you have any questions, you can drop in the comment section, but make sure you go through these examples over and over again. So this concept is what you need. Any questions they give you on current electricity like this, you will be applying this concept. So you need to apply the concept critically to get the best out of it. Thank you for watching this video. Like this video, subscribe to this YouTube channel, and you can share. Make sure you share it to your friend and let them benefit of this video. Thanks, and God bless.